Let's move to section 4. All right, so in that section, we basically just learned the power rule, all right? And we learned that if you're adding two functions together, it's just the derivative of the first plus derivative of the second, or subtraction, same thing. What if you're multiplying two functions or dividing? Okay, that brings us to the product and the quotient rule. Okay, so let's see if there's anything else. And then the more general form of the power rule. All right, so really just product and quotient on this one. So if you've got a product, so you've got some function f of x times some function g of x, okay? If you want to take the derivative of that product, all right, then now, I normally do it the different order than what it's got here on the screen. What I normally do is the derivative of the first times the second plus the first times derivative of the second. Okay? Now, notice all you've got there is multiplication and addition. So multiplication and addition are all commutative. So you can change the order up with this. It's not a big deal. So as long as you take the derivative of one times the other plus the derivative of the other times the other one and add them, you're good. Okay? So think up there it's got, well no, that's what it does. So derivative of first times the second plus the first times derivative of the second. Okay, that's it. That's the product rule. Okay? That one's not too hard to remember. That one's not too bad. Quotient rule. All right, say that we want to do the same thing except with a quotient. So we're going to divide f by g. Well, remember, anytime that you're dividing or subtracting, order matters. Okay? 1 minus 2 is not the same thing as 2 minus 1. 1 divided by 2 is not the same thing as 2 divided by 1. So you've got to be sure you follow the right order. All right, so what you do, and you just got to remember this, okay? If you've taken this in high school, in an AP class or something, they come up with these little phrases when you're in high school, you know, for things. So some kind of bottoms up thing or something maybe, I don't know. You ever heard that before? Okay. Well, you start with the bottom, okay? So it's the bottom times the derivative of the top. So it would be gx times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. That is the quotient rule. Okay? Now, again, main thing to remember is you got to have the right order of everything because you're subtracting and dividing. You start with the bottom. So you always start with the bottom part of the fraction. So it's the bottom times derivative of the top minus top times derivative of the bottom and then divided by the bottom squared. And that is quotient rule. All right, questions about that? All right, let's do some of these. So this says find and simplify the derivatives of the following functions. Okay, now this one we could do by multiplying out and using our power rule if you wanted to, but we're in this section on product. So let's do it as a product, okay? You can check it the other way if you want to, I guess, but I'm going to use the product rule. All right, so I'm going to do derivative of the f. I'm going to try to stick with the order they got there. All right, so the derivative of the first times the second. So what is the derivative of 3x to the fourth? 12x to the third times the second plus the first times the derivative of the second. What is the derivative of 2x squared minus 1? 4x. Okay? So derivative of the first times the second plus the first times derivative of the second. Okay? Simplify it. 24x to the fifth minus 12x cubed plus 12x to the fifth So we end up with there 36x to the 5th minus 12x cubed. Okay. Now, if you took that and multiplied out and did the derivative, you should get the same thing. All right, questions about that? Now, we've got a difference here. So remember, minus and add, they go together, right? So I should be able to just take the derivative of the first one minus the derivative of the second. All right, so that's no problem. So g prime x, derivative of 6x is 6, right? Minus. Now, what is going on here with this second one? It's what? Multiplication. You've got and it's always, you always think of this as a function of x times a function of x, right? Doesn't matter if you're multiplying a number. You could, I mean, the rule will work if you just have a constant, but there's no reason to do it if it's a constant. But notice you've got a function of x, you got 2x, and you got another function of x, e to the x power. So here I've got to use the product rule in order to do the derivative for that. So, and since you're doing subtraction, I definitely would use a parenthesis symbol there. Okay? So I'm going to say the derivative of the first times the second. So the derivative of 2x is 2 times e to the x. And then plus the first times derivative of the second. Well, 2x times, what is the derivative of e to the x? E to the x. There you go. And now just, you can probably get rid of that parentheses, would be good there. So this will be 6 minus 2e to the x minus 2x e to the x. All right. Questions about that? Now, this is not one where you could, of course, you could factor an x out of the top, but then you get x squared minus 4x plus 1, which will not factor. That is prime. So it's not going to help any to factor it. So you could not do this one the way that we did them in the last section. Okay? Got to use the quotient rule. Okay? So with the quotient rule. All right, so where do we start with the quotient rule? We start with the bottom. All right, bottom. So x minus 2, the bottom, times the derivative of the top. So the derivative of x cubed minus 4x squared plus x would be 2x squared minus 8x plus 1. So that is the bottom times derivative of the top minus top times the derivative of the bottom. What is the derivative of x minus 2? What's the derivative? 1. And then over the bottom squared. Okay, any questions about that step? So now I will have, when I multiply this out, 3x cubed minus 8x squared plus x. All right, then minus 6x squared plus 16x minus 2, and then minus x cubed plus 4x squared minus x over x minus 2 squared. Okay? I think that's right that time. All right, now let's combine terms. All right, so 3x cubed minus x cubed is 2x cubed. Negative 8x squared minus 6, negative 14 plus 4 is negative 10x squared. And then x and 6, well, let's see, x minus x0, so that just leaves 16x. Then I got minus 2 over x minus 2 squared. There you go. All right, questions about that one? Now notice if I were to distribute that out, I'm going to have two products, because I'm going to have 5w squared times EW, which is a product of two functions, and the same thing here. So why not just leave it like it is, and I'm going to take this EW, that's function, multiply times the second, just use the product rule. Okay, so G prime W equals, all right, the first times, well, let's see, how am I doing? Derivative of the first times the second. All right, so derivative of e to the w would be what? E to the w? So that's the derivative of the first, then times the second, plus the first EW times derivative of the second. So the derivative of 5W squared plus 3W plus 1 would be 10W plus 3. Okay? Now let's see what we could do there. Now notice, rather than multiplying all this out and everything, just notice you've got EW times this plus EW times this. So really you got a term here and a term here. So I would just factor out the E to the W from the two terms. That would give you EW times 5W squared plus 3W plus 1, and then plus the 10W plus 3. So I just factored the EW out of both of them. And now just combine terms. There you go. Quotient, all right, quotient rule. So derivative of f is equal to, all right, so I would take the bottom first. So it's the bottom times derivative of the top. What is the derivative of e to the x? E to the x minus, okay, got to have a minus sign there, top times derivative of the bottom. So e to the x, what is the derivative of e to the x plus 1? Just e to the x. Derivative of 0 of 1 is 0. So times e to the x over the bottom squared. Okay, so this will be, I'm going to leave the bottom like it is. All right, so here I'll say e to the x times e to the x is e to the 2x. 1 times e to the x is e to the x. Then here minus e to the x times e to the x is e to the 2x. So the e to the 2x is subtract off. The derivative then is e to the x over e to the x plus 1 squared. All right, so that negative 1 there, what did I do with that negative 1 exponent?
You can put the 2t over 2 on the bottom.
All right, you can move the 2t to minus 2 to the bottom, and that changes the sign of the exponent. So I would need to rewrite this. So I would rewrite it as 3t minus 1 over 2t minus 2. Okay? Now I can do the derivative, all right, with what I know up to this point. What rule do I have to use for that one? Quotient rule, all right. So remember, with the quotient rule, we start where? With the bottom. So I do the bottom times derivative of the top. Derivative of 3t minus 1 is 3. Minus the top times the derivative of the bottom, which is 2. Over the bottom squared. Okay? Now again, the bottom is in a factored form. I just leave it like it is. The top, though, we need to kind of reduce it a bit, combine some terms. So I'd have 6t minus 6. All right, and then notice over here I've got 6t minus 2, but I've got a subtraction sign in front. So let's do minus 6t plus 2. So now the 6t minus 6t is 0. Negative 6 plus 2 is negative 4. So let's write our answer as negative 4 over 2t minus 2 squared. Now I can reduce that a little more algebraically. What do you notice in the bottom here? They'll still have a factor of what? Factor of 2. So if I have 2t minus 2 squared, that's the same thing as this, right? Which is the same thing as this. which is the same thing as this. Everybody follow that? So this is the same thing as negative 4 over 4 times t minus 1 squared. And then what can I do with the 4's then? Divide those out. So negative 1 over t minus 1 squared. All right, any questions? All right, Wednesday, we will pick up, finish up product and quotient rule, move on to trig, differentiation with trig functions. All right, well, last time we were finding derivatives using a product rule and chain rule. So let's do a few more of those problems this time. So let's start with this one. So let's say we have h of w equals w squared minus 1 over w squared plus 1. Okay. Now this is a function of w, so the independent variable is w, but it's just like same thing as if it was x. The w squared minus 1, you could factor that to be w minus 1, w plus 1, but that wouldn't help any with the bottom. So all you can do is just do the quotient rule to find the derivative of the function. So let's do that. All right, so our derivative will be, all right, so remember, if it's a quotient, start with the bottom. So it's going to be the bottom times the derivative of the top. All right, what is the derivative of w squared minus 1? Okay, what? 2w, right, and then derivative of 1 is 0. So 2w minus the top times derivative of the bottom. What's the derivative of the bottom?
2w.
It's also 2w. So I got 2w there over the bottom squared. Okay. Any questions about that first step? Now I would leave the bottom like it is. There's no reason really to multiply that out. The bottom, when you square it, that's really in a factored form. So just leave it like it is. The top, though, we do need to multiply it out and see if we can reduce it a little bit or something. So I guess let's go ahead and distribute. You could factor a 2w out if you wanted to, but that might be a little faster. But let's just distribute. It really doesn't matter either way. So 2w cubed plus 2w. Now here, be careful. I want to say negative 2w times w squared is negative 2w cubed. Negative 2w times negative 1 will be a plus 2w. All right. Now in the numerator, the 2w cubed minus 2w cubed, that's just 0. So I have 4w over w squared plus 1 squared. That would be the derivative function. Okay? Questions about that? Now notice on this one, in the denominator here, you've got x squared e to the x. So here you have a function of x times a function of x. Right? So whenever I find the derivative of the denominator, I'm going to have to use the product rule for that. Okay? So let's do it. All right, so the derivative is, all right, using the quotient rule, which is the main thing's a quotient. We start with the bottom, so I do the bottom times derivative of the top. So I would have x squared e to the x times, what is the derivative of x plus 1? Just 1. Minus the top times derivative of the bottom. Now, the bottom is a product. Got to use the product rule in order to differentiate the bottom. Okay? So on the bottom, I will say, so x squared e to the x. I'm going to say the derivative of the first times the second. So the derivative of x squared is 2x. So 2x e to the x plus the first times derivative of the second. What is this derivative of e to the x? E to the x. All right, that was on our quiz, right? So that's just going to be x squared e to the x. So that's the derivative of the first times the second plus the first times derivative of the second. Okay. So I've done the bottom times the derivative of the top minus the top times the derivative of the bottom, and then it's over the bottom squared. Okay, so any questions about that first, that main step there? All right, we just need to reduce. Okay, so since the bottom is one term, I'd go ahead and square it would be easy. So this would be x to the fourth e to the 2x on the bottom, if you square both of those. Now on the top we would have x squared e to the x. And now here, why don't we do minus and do parentheses, and then I need to distribute this out. So x times 2x e to the x will be 2x squared e to the x. And then x times x squared e to the x will be x cubed e to the x. And then 1 times each of those is just 2x e to the x plus x squared e to the x. Okay, so now let's see what we can do here. All right, so I would have, are any of these alike? So this one and this one are alike, and that's probably it. So I can say x squared e to the x minus 2x squared e to the x would give me a negative 1 x squared e to the x. Okay? So let's do that. So minus x squared e to the x. And then that'll be a minus x cubed e to the x minus 2x e to the x. Got another one there. Okay, so another one. So that will give me 3, so 1 minus 3, that'd give me a negative 2 x squared e to the x. Okay? What is common to all those terms on the top? E to the x and what else? X. So let's factor out and let's do a negative too. Why not? So we would have a negative x e to the x. We'll factor out of the top. So that will give me 2x plus x squared plus 2. Over this. Okay. And now that I've got multiplication here, I can divide these out a bit. So my x divided by x to the fourth, that'll give me an x cubed in the bottom. X e to the x divided by e to the 2x would leave me with an e to the x on the bottom if I subtract 2x minus x. So my answer then would be, over here, negative x squared plus 2x plus 2 over x cubed e to the x. That would be a nice reduced form for that derivative function. So here we got a function of r. We want to find the derivative. Okay, so quotient rule. Okay, so I've got to, so first I would do, with all we know with derivatives at this point is power rule and then product and quotient. So anytime we got a square root here, we're going to want to make that into an exponent. So I'm going to just rewrite that as r to the 1/2. Okay, so h prime of r will be bottom times derivative of the top. All right, so the derivative of the top, derivative of 2 would just be 0. Negative r, what's the derivative of that? Negative 1. And then negative r to the 1/2, What would that be? Well, multiply by half and subtract 1 from the exponent. So 1/2 r to the negative 1/2. Okay. So that's the bottom times derivative of the top. Now minus the top times derivative of the bottom, which the derivative of r plus 1 is just 1 over the bottom squared. Okay, questions about that? All right, now we just got to reduce this a bit. All right, so let's see. Went ahead and distributed everything here. All right, so let's do that. So here I got a binomial times a binomial, so let's multiply. R times negative 1 is negative r. R times negative 1/2, r to the negative 1/2. R times r, or r times r to the negative 1/2, I just add 1 minus, plus negative 1/2, and that gives me positive 1/2. So that would be minus 1/2 r to the 1/2 when I multiply. Okay? And now 1 times each one, I get negative 1 minus 1/2. Now I have r to the negative 1/2. Then here I've got minus 2 plus r to the 1/2 over r plus 1 squared. Okay? Any questions? Now, notice, before doing anything else, notice the r's here. I've got a minus r and a plus r. Those will just kind of subtract each other off there. So those go away. Let's go ahead and let's change these 1/2s back to square roots. So I'm going to have square root r, and here, since I've got a negative 1/2 exponent, let's go ahead and move that into the denominator of that fraction. And let's write it like that. Okay. Now I have a fraction inside of a fraction. I have 1/2 here, and I have 1 over 2 root r here. So if I have a fraction inside a fraction, how can I reduce that so I don't have that? What do I multiply the top and bottom by?
That fraction, the common denominator?
It's common denominator, right. So if you look at it, I take all the fractions, common denominator, the only denominator, really, we got 2 and 2 root r. So the common denominator would be 2 root r. So just multiply the top and bottom by that, and that should fix it to where we don't have those fractions inside the fractions. Okay. All right, so on the bottom, that would just give me 2 root r times r plus 1 squared. Okay. On the top, let's distribute. So 2 root r times negative 1/2 root r. 1/2 times 2 is 1. Root r times root r is r. So that'd be a minus r. Okay. Minus 1 times 2 root r will be minus 2 root r. Now I've got the fraction 1 over 2 root r times 2 root r, so that will cancel that out altogether. The 2 root r cancels with that one, so that would be minus 1. And then I got minus 2 times 2 root r, so that'll be minus 4 root r. And then root r times 2 root r would be 2r. Okay? Questions? Just combine terms now. So we would have, let's see, negative r plus 2r will be r. Negative 6 root r minus 4 root r would be negative 6 root r. Then I got it minus 1 over 2 root r r plus 1 squared. It's like a good answer. All right, so that would be the derivative function for that function. Any questions about that? Product and quotient rule. All right, let me go back over here real quick. So the next thing, I think we've got one question that says find an equation of the tangent line. Okay, so this says find an equation of the tangent line to the given curve at A, and then use graphing utility to graph the curve and the tangent line on the same set of axes. All right, so we just want to find the slope, the actual tangent line at the point given. Okay, so what we want to do is find the derivative first, and then the derivative is the function that produces the slope of the tangent line at points. All right, so let's find our derivative first. We got y equals 2x squared over 3x minus 1. Okay, so first let's find our derivative. We have a quotient. All right, so derivative is, all right, the bottom times the derivative of the top. Derivative of 2x squared, just use the power rule. 2 times 2 is 4. 1 from 2 is 1, so that would be 4x minus the top, 2x squared, times derivative of the bottom. 3x minus 1, derivative would just be 3. Over the bottom squared. Okay? Any questions about that first step? Now, it did not say find the function of the derivative. Right? It just said that we want the tangent line. Right? So you don't have to do a lot of reducing necessarily. I'd probably go ahead and multiply this out. But anytime a question asks you to find the equation of the tangent line, that doesn't mean that it's wanting a function for the derivative reduced and all of that. You just got to find the slope. So I think here I'll just go ahead and distribute a little bit here. So that'd be 12x squared minus 4x, and then I got minus 6x squared. I guess you could put those together pretty easy. So I get 6x squared minus 4x over 3x minus 1 squared. Okay, that's not too much. All right. So that function is the derivative, and it will generate the slope of the tangent line at any point there on the graph where it's differentiable. All right. So we want to know when a is 1. So in other words, when x is 1, what's this tangent line? Okay. So if I take 1 and I plug that into this derivative, okay. So I'm going to take the derivative and I'm going to plug 1 into it. Okay. Then I just take, everywhere I see x, put a 1 in. Okay. So that'd be 6 minus 4, that'll be 2 over 3 minus 1 is 2. 2 squared is 4. So the derivative, the slope of the tangent line at 1 is 1/2. Okay? Now, how do I write the equation of a tangent line? What do I need to start with? What do you start with?
The line or stuff?
Okay. You could do y equals mx plus b. What did we do in the past? Okay. When that's called, what's that called? You remember? Point slope form. If you got point and slope, you got point slope form. So it is this. All right. So this is one thing you nearly need to remember. Okay. Y minus y1 equals mx minus x1. All right. So that is your slope. So that goes right there for m. All right. We got x. We got y. I just need a point now that's on the line. Any point will do. Well, I'm looking at the one point on the line that I know, that is when x is 1. So if x is 1, I need a y coordinate, okay? And this is on the graph of the function. So to find this value here, I go back to the function and plug in 1. So I have 2 times 1 over 3 times 1 minus 1, so that's going to be 2 over 2. Looks like the y value there would be 1 as well. Okay? Again, that's from plugging it into the function, not the derivative, but the function. So here I'll say y minus 1 equals 1/2 x minus 1. Okay? Normally we put it in slope-intercept or something similar, so let's do this. And then if I add 1 to both sides, negative 1/2 plus 1, that'll be positive 1/2. That should be my line. Okay? Questions about that? You'll take your graph and utility. Let's see, it's already up there. And put the function in. So I'm going to say 2x squared divided by 3x minus 1. All right, so there is the function. All right there. Has a slant asymptote. All right, so now let's graph our tangent line. So we've got y equals 1/2 x plus 1/2. Okay. So notice Desmos will show you where the graphs are sharing a point. All right, so notice this is the point it's sharing, and that point is 1, 1. So it's tangent right there at 1, 1. Okay? Looks like we did good. All right, so any questions about that? All right. All right, a couple more little problems here. Let's do one where we find a second and third derivative as well. Directions. Find first derivative, second derivative, third derivative. Okay, we want to find those. All right, so f of x, so we got f of x equals x squared times 2 plus x to the negative 3 power. Let's do one of these. All right, so you could multiply that out, you could distribute that out, make it a little simpler, but we want to use what we do in this section, which is product rule. So let's do the product rule. Okay, so if I do use the product rule for this, first derivative, then I would just, in whatever order you want to go in, I'm used to doing the first times the derivative of the second and then reversing it. So it really doesn't matter. Let me try to do what we had on the paper. So I'm going to do the derivative of the first times the second. So that'll be 2x times 2 plus x to the negative 3, okay, plus the first times derivative of the second, okay. Now the derivative of the second here, you've got the derivative of 2 is 0, plus the derivative of x to the negative third, you'd multiply by negative 3 and then subtract 1 from the exponent. So that would be a negative 3x to the negative 4. Okay. Questions about that? Now that's enough for the product rule. Let's distribute this out. And so that would be 4x plus 2x. So if I multiply x times x to the negative 3, I add exponents. 1 minus 3 would be negative 2. And that'll be a minus 3x to the negative 2. Okay. So this would be 4x. So 2 minus 3, that'd be a minus 1. So I guess I could say minus 1 over x. Let's do this. Let's say minus x to the negative 2. And then for my official first derivative answer without the negative exponent, let's say 4x minus 1 over x squared. Okay? So that would be my first derivative. Okay. Now to do the second derivative, we just take the derivative of the first derivative, right? So let's go here and let's take this one and do that. Okay. So 4x, the derivative would be 4. And then minus x to the negative 2, I use the power rule, multiply negative 2 times negative 1 would be a positive 2. X, subtract 1 from the exponent, that would be a minus 3. Okay, so the reduced second derivative would be 4 plus 2 over x to the third. Okay. Third derivative. All right, let's take the derivative of this one. Derivative of 4 is 0. 2x to the negative third, the power rule, negative 3 times 2 is negative 6. Subtract 1 from the exponent, I get a minus 4. So I got negative 6 over x to the positive 4 power. So that would be my first, second, and third derivatives of that function. F of 2 is equal to 2, and f prime at 2 is equal to 3. Let g of x equals x squared times f of x, and h of x equals f of x divided by x minus 3. Okay? So the A part says find an equation of the tangent line of the tangent line or line tangent to y equals g of x at x equals 2. Okay? All right, it's a little different than just saying find the derivative, all right? Okay, so let's look at what it's asking. All right, so we got y equals g of x. Let's say the line tangent there. Let me turn that around, I'm sorry. All right, so find an equation of the line tangent to this at x equals 2. So we want to do this finally, right? That's what we want to do to get the line tangent. So to do this, what do we need? We need a point on the graph, right? And we need what else? Slope of the tangent line, okay? Which is the derivative, okay? We need to go back to the function. Now, the function is not f that we're finding, it's g of x, right? So if I go to g of x is x squared times f of x. Okay, so to get my point, x1, y1, okay, then x is 2. All right, to get y, I need to find g at 2. Okay, so g at 2 would be 2 squared times f at 2. What is f at 2? 2. So this would be 4 times 2, which is 8. So my point for g of x is actually 2, 8. That's the point where I want the slope of the tangent line. So any questions about that? Now, to find m, I need the slope of the tangent line. Now, and it's not f, though. This is going to be of g. So let's take what g is here. And let's find the derivative. Okay, how do you find the derivative of that? You've got x squared times f of x. So what do you use? The product rule. All right. So I would say the derivative of the first, which is 2x, times the derivative of times the second, plus the first times derivative of the second. All right, does that make sense? Now I want to know, to get my equation of my tangent line, what is my slope at 2, right? We'll just plug 2 in for x. So I would have 2 times 2 times f at 2 plus 2 squared times f prime at 2. All right? F at 2 is 2, f prime at 2 is 3. So I got 2 times 2 times 2 plus 4 times 3. So that would be 8 plus 12. That will give me a slope of 20. Okay, any questions about that? So now I've got slope, I've got a point. So let's do y minus 8 equals 20, x minus 2. And then again, slope-intercept forms, usually where we want to go. $20x minus 32. That would be my slope of my tangent line. Okay. Questions about that one? All right. So the B part. Find an equation of the line tangent to y equals h of x at x equals 2. Okay, so now you've got the h function there, all right? Do the same thing we did, except do that with the h function. Equation of the tangent line when x is 2. Okay, so pencil, paper, y'all try it first, see if you can, see what you can do. Well, it told us h of x was f of x over x minus 3. Okay, so we've got that. So I need to know the derivative in order to be able to find this tangent line, right? It's got to have the slope. So this is a quotient, right? So if you use the quotient rule to find the derivative, it is the bottom times derivative of the top minus the top times derivative of the bottom over the bottom squared. Okay, so we got that. Now, I don't need to do anything else as far as reducing it. Really, you can anyway. But now I need to know, well, what is the slope of that tangent line when x is 2? So let's find h prime at 2. So where I see x in there, I'm going to put in a 2. So I would have 2 minus 3, f prime at 2, minus f of 2, of course, times 1 is just, that goes away, and then 2 minus 3 on the bottom. And then I would say, well, will they tell me what f prime of 2 and f of 2 was? F of 2 is 2, f prime of 2 is 3. So this will be negative 1 times f prime of 2 is 3 minus f of 2 is 2 over 2 minus 3 is negative 1 squared. So it looks like I've got negative 3 minus 2, slope of negative 5. So that would be my slope of my tangent line when x is 2. So any questions about that? All right. Only other thing I need then is a point, whatever the point is when x is 2. So to do point slope form, I need that. So for that, I go back to the original function. So if I find h at 2, that's going to be f of 2 over 2 minus 3. Okay. So f of 2 is 2. 2 minus 3 is negative 1. So my x-coordinate should be negative 2 when x is 2 for the h function. So my point then would be 2, negative 2. All right? Put all that in. So I have y minus the y coordinate. Y minus negative 2 will be plus 2 equals the slope negative 5 x minus the x coordinate 2. All right. Do a little algebra here. Negative 5x plus 10, subtract 2, y equals negative 5x plus 8. That would be the slope, that would be the line tangent at the point 2. All right, any questions about that? And all this is just when x is 1, f of x is 5, f prime of x is 3, g of x is 4, g prime of x is 2, so on and so forth, okay? So let's say that we want to know the derivative with respect to x of f of x divided by x plus 2. Then they're using this notation here, which is fine. We want to know when x is 4, okay? So again, the notation here, d dx, that means you're taking the derivative with respect to x of that, is what it means, all right? So if I take the derivative of that, I have a quotient. I got a function of x on the top, function of x on the bottom, so I have to use quotient rule, right? So bottom, so this is equal to the bottom times derivative of the top minus the top times derivative of the bottom. Derivative of x plus 2 is just 1. So I'm going to write it over the bottom squared. Okay? Now at 4, I'm just going to plug 4 into this. Okay, so this will be 4 plus 2 times f prime at 4 minus f of 4 over 4 plus 2 squared, okay? All right, 4 plus 2 is 6. All right, what is f prime at 4? Okay, go this chart. What is f prime at 4? It is 1. When x is 4, f prime is 1. So I put a 1 right there. Minus, what is f at 4? Here's 4, f of x is 2. Over 4 plus 2 is 6, 6 squared. So this will be 4 over 36. That'll be 1 over 9. Okay, so if we find the derivative of this, now notice we have a quotient. I also have a product on the top. So we got to be sure we follow our rules there. So let's just take the derivative with respect to x of that. All right, so it's a quotient. That's the main thing, it's a quotient. So let's follow the quotient rule. The bottom, start with the bottom, times derivative of the top. Now the top is a product, so I got to use the product rule to differentiate the top. So the top, I would say the derivative of the first, so f prime times the second, g, plus the first times derivative of the second. Okay? Now, what have I done? I've done the bottom times derivative of the top. Still got to do minus the top times derivative of the bottom. Okay? Derivative of x is 1. So that's just going to be f of x times g of x over the bottom squared. Okay? Questions about any of that? Now I won't try to do any reducing, there's no need to. All right? Let's just plug in our numbers because all we're looking for is the derivative at x equals 4. Okay? So I'm going to say at x equals 4. All right, then I will have, all right, so when x is 4, that's a 4 right there. I've got f prime of x. What is f prime of x at 4? F prime 1 times g at 4. All right, well here's g. Here's 4. G of x is equal to 3 when x is 4. Plus f of x, so f at 4, f of x will be 2, times g prime of x, so g prime at 4, there's 4, g prime is 1, minus f at 4, 2, times g at 4, which is 3, over x squared be 4 squared. Okay? So what does all that equal? 4, that'll be 3 plus 2 will be 5, so this will be 4 times 5 minus 6 over 16. That'll give you 14 over 16, 7/8. Okay? All right, any questions? Quotient product rule. You need to practice it, okay? If you just sit and watch me, then chances are you're not going to learn to do it if you don't do it. Try it yourself. So you might be one of the exceptions, but there aren't that many exceptions, okay? So you got to practice. So, all right. Okay, so next section.